Welcome back, everyone. We're going to be solving LeetCode 680, valid palindrome 2. So we're given a string s. We need to return true if the string s can be a palindrome after deleting at most one character from it. So if we take a look at the examples, example 1 is ABA returns true because this is a palindrome without deleting any characters. 2 is a palindrome because we can delete C, and then ABA is the same as ABA. And then ABC, false, right? If we can't delete any character in here and make this a palindrome. So we can use 2 pointers to solve this problem. So we'll say left is equal to 0, right will be equal to the very last position in our string, which is going to be the length of s minus 1. So now what do we need to do? Now we need to loop through this string while our left and right pointers have not crossed, right? So we can say while our left pointer is less than our right pointer. What do we want to do? Well, if it's a palindrome, the characters at both of the pointers or at both ends of the string should be the exact same character. So we can say if s of L, our left pointer, is not equal to s of our right pointer, right? So in this case, example 1, A is equal to A, so we would not execute this. But example 3, A would be our left pointer, C would be our right pointer, then we would execute this block. So what do we want to do in this block? We want to delete one character from either the left side of the string and check if the rest of the string is a palindrome, or delete one character from the right side of the string and then check if the rest of the string is a palindrome. How can we do that? We can say return s of our left pointer all the way up to our right pointer. Why? Because this is non-inclusive, right? So if we're at 0 and 2, right, left would be at A, right would be at A. This right here would result in just AB. So this is deleting 1 from the right side. So we want to check if this string is equal to that string reversed, the reverse of this string, right? Or, right, because this is deleting 1 character from the right side, now we need to delete 1 character from the left side. So how can we do that? Well, it's going to be the exact same, except we will add 1 to both the left pointer, right? Instead of at position 0, it'll now be at position 1. So let's add 1 to the left. And we want to include our right pointer this time. So now we have to add 1 to our right pointer. So our right pointer, the character at our right pointer, is included in this. Now, what if that'll handle the case for checking, deleting 1 character and checking if either string is a palindrome. Okay, so what happens if our left and right pointers, if the characters at those 2 positions are equal to each other? Then we can simply just increment our left pointer or decrement our right pointer. And if we ever exit this while loop, that means our string already is a palindrome, and we can just do a latent return true. So let's get rid of some of these spaces here and we'll run this. We pass all 3 test cases, so we'll submit. And it does pass, perfect. So what is the time complexity of this? The time complexity is going to be O of n. At worst case, we are going to touch every character inside of our string. So our time complexity is going to be O of n. The space complexity, you might want to say, is O of 1, because we're not creating, it doesn't look like we're creating any new data structures, but because we are doing this right here, these operations create new strings. So our space complexity is actually going to be O of n for this problem. And that'll do it for LeetCode 680.